Now, we're going to do some examples here, so fasten your seatbelts doubly. Here we go. Right, we're going to let f of x equal x squared, and we're going to let g of x equal root x. And we're going to find f of g of x, and we're going to sketch its graph. Let's do that. So let's get the assembly line diagram happening. I prefer to do it this way because it's more visual than the domain range table, but you make your choice. Once you really understand this, I think you're free to choose whichever you like, okay? But this is the more visual way of the two. Okay, so in this case we're doing f of g of x, therefore g is stage 1 and f is stage 2. Now, here's a little visual roadmap of what's going on normally with g of x. Okay, so its input would be from 0, including 0 up to infinity. Its output or its range would also be the same. There's a little visual representation of what happens graphically. Yeah? Alright, now let's examine f of x now. Without any influence from g of x, its normal domain would be all real numbers, wouldn't it? Yeah? It's just a quadratic. And its range would be also from 0, including 0, up to infinity. Alright? Now we've got to examine any compatibility issues which might exist here. Alright? Now the range of g is wholly contained within the domain of f. So we haven't got a problem in terms of the composite function being not defined. It is defined, it's okay, alright? So what we're saying is that this is wholly contained within that. Just pictorially you can see it. Yeah, so it's not an issue, it's defined. Hence, f of g of x does exist. And we know that the domain of fog, therefore, is the domain of the left-hand side of it, which is from 0, including 0, up to infinity, okay? It's the domain of g of x, yeah? And the range of fog is basically what comes out this end. Now, you have to understand, ladies and gentlemen, that if this is the output of the first stage, it's also the input into the second stage. So even though this beastie normally has a domain of R, it's not getting R as its input. It's just getting that. It's just getting that. So this function is getting a restricted domain as far as it's concerned. It's just getting the right-hand side of the x's on the right-hand side of the y-axis, including 0. That's all it's getting. Can you see that? See, think of the assembly line again. Think of the assembly line. Okay? This is very important for us if we are required to sketch the graph of fog. Alright, let's keep going. So we know that, just summarising again, we know that the domain of fog is going to be the domain of G, and the range of fog is going to be whatever comes out this right-hand end. Now, with a restricted domain, if you like, in terms of what it naturally likes, it's getting from 0 to infinity going in. So look at the graph. What's going to come out? The y values corresponding to the right-hand side of this graph in terms of its x values is still from 0 to infinity. So that's what's going to come out the right-hand end. Are you getting me? Think about that. That's really important to get that. Now we're going to come up with the algebraic equation for what fog is. Okay, so f of g of x is actually not x squared but g of x squared. Okay, now that's going to be root x all squared, which just comes out to be x, but the domain of it is going to be this one here, from 0 to infinity. Okay, do you see that? And there she be. Okay, from 0 to infinity. So it's y equals x from 0, including the 0, up to infinity. Okay, that is the domain there. Okay, and that is the range there. Okay, the compatibility issues are okay. It's very important to understand what goes on between here and here in order for you to fully understand how these beastly things work. Yes? Terrific.